Hello and welcome to the next lesson in the C# for Beginners playlist. Today we are going to learn how to use classes because we know what they are, objects, but we are yet to see how they are properly used. So let's roll. When you declare a class, let's say you want to emulate a book in code. We already saw in previous lessons how you do that, something like this. But what I want you to understand from the very beginning is that this is not a book that you can actually sell. This is what's called a manuscript. So when a writer writes a book, that's called a manuscript and it's unique. No one else has it but the writer. And if the writer wants to sell that book, they will not sell the manuscript itself and rewrite it every single time they want to sell it again. Instead, they will make copies from it and sell those copies. It is the same principle for cars and airplanes. When engineers create a new car or airplane, there's just the blueprint, the prototype. And if they want to sell it, again, they will not sell the prototype, the blueprint, they will create copies from it and sell the copies. And I want you to sear this concept on the back of your eyelids because this is the key to this entire object-oriented programming thing. It will make it really easy. Usually, we do not manipulate blueprints, manuscripts, etc. The original object itself, we create copies from it and we manipulate those copies. In programming, we call these copies instances. So when you hear me say something like, let's create an instance of type book, what I'll actually mean is, let's create a copy of this book manuscript. So let's do that. Let's instantiate a variable of type book. But first, let's make our lives easier and also learn a new trick in Visual Studio. Right-click on the header and choose New Vertical Document Group, so we can see both files side by side. And now let's declare our variable. That's it. This is just as if we'd written something like, we have a variable of type string called name and we have a variable of type book called my book. You already know strings are reference types, which means they are stored on the heap and the stack cell points to that cell on the heap. And if they are not initialized, so they don't have a value, the stack cell points to nothing on the heap, which means the string is null. It has a null value. If you don't know what I'm talking about, I explained all this in the lesson about nullability. Check the reference. This is exactly the same for classes too, because classes are also reference types. So when we say book, my book, this is a variable of type book or reference, but it's just declared. This is just a declaration, it's not initialized. So the variable is null. The stack cell points to nothing on the heap. To initialize a string, we assign it a value directly. What you don't know is that we can also do it like this. The new operator is the one that allows us to instantiate, to copy a new string. So that's why it says new string, because it's a new copy, a new instance. That's also how we create a new instance of type book or any other class type. So, and here, new book creates a new copy of type book, which is put in this variable, my book. My book is now a new copy of type book. Let's get rid of this string, we don't need it anymore. And since we have a variable of type book, let's start using it. If I type my book dot, we have title, which is the variable in the class, and cell, which is the method in the class. So through this copy, through this instance, through this variable, we can access stuff, we can customize things, we can give them values, etc. So, but this doesn't tell us much. Okay, I have a copy of type book and this title is the Fellowship of the Ring. But so what? What do I do with it? Well, this is where the beauty of instantiation come in. Well, I can create a new copy . And now we have two independent copies of type book, each containing its own data. So from now on, my book and your book are independent. They hold their own values. They are independent of each other. This simply means that I can have 1000 instances, 1000 copies of type book, invoice, product, student, whatever my class is, and each individual copy has its own data. This invoice total is not the same as that invoice total. And this means that we can have variables that can engulf multiple other variables, each with their own individual data. And that's amazing because I can have, for example, arrays of type book. I can do so many things. And The original blueprint doesn't specify a title for the book. It only specifies that the book can have a title. In official programming manuals, you'll encounter often two terms: the state of an object and its behavior. The state is individual for each individual copy. Like in our case, the title can be different for each individual copy. On the other hand, the behavior is common because, for example, the method cell is the same for all of them. It will be the same every time, all the time. The code inside it doesn't change. So we can say that the behavior is common for all of them. All books can be sold, while the state is individual. One book's title can be different from the other's book title. Now that you know what instantiation is, let's also see how it's performed. When we say book my book equals new book, this does something very specific. It's calling a pseudo method called a constructor. So if we go back to the book class, we can manually add a constructor like this. And the first thing to notice about this pseudo method is that it's a bit unusual. I mean, it has a block of code, it has parentheses for parameters, it does return something of type book, but it has no name. That's why I called it a pseudo method. It might look like one, but it's not quite like one. And the reason why it's called a constructor is that it has a very specific role. It creates a copy of this class. So when we say book my book equals new book with this parenthesis as if we are calling a method, we are kind of actually are, because we are calling this pseudo method, this constructor. This is easily provable by putting a breakpoint and running the program. We are hitting it. So when we instantiate something, we call the constructor and it's returning a new copy of this book. Also notice that the call itself is a bit unusual as opposed to normal method calls, because we need to use this new keyword. If we delete it, we will get an error. We cannot just call it as if it was a regular method. So the whole purpose of the constructor is to create a copy of the class it lives in. That's why it needs no name. That's why the return type must be the same as the class it lives in our case, book. But you'll hear some programmers mistakenly state that the name of the constructor must be the same as the class it lives in. What they don't realize is that there's not the name, there's the return type, which must be the same as the class it lives in. If you try to return something else other than the class it lives in, like this, you'll get an error. Method must have a return type. That's because console is not the same as book, which means this is not a constructor, but it also doesn't have a name, so it's also not a regular method. In fact, you'll also get an error if you try to declare a regular method with the same name as the class it lives in, like this. In this case, the error will be book. Member names cannot be the same as their enclosing type. So only constructor can have just the return type, and it must be of the same type as the class it lives in. What are constructors used for? Well, other than creating copies of the class they live in, since they are methods, we can treat them like ones. So we can put code to be executed when we invoke them, but you should be careful about that because constructors are not intended for heavy lifting or long-lasting operations. So don't download files, don't make database calls, don't do computations that take 50 minutes to complete, yada yada yada. That's very bad practice. Instead, since they are used to create objects, that should be almost instantaneous, blazingly fast. So the purpose of the constructor used as a method should be to serve you with the stuff that needs to be there when you receive the copy of the object. Stuff like allocating memory, initializing stuff, setting default values for your variable, resetting things, etc. Of course, there are cases when you do need heavy lifting or long-lasting operations, and for those cases you should create methods like load or initialize and call them on the object that was just created. So in my case, mybook.load or mybook.initialize. But since constructors are pseudo methods, they can have parameters just like regular methods. So we could try to do something like this. And now we get errors where we try to instantiate this class because, of course, we are asking for a string, but we are not giving it any. So let's do that. And also let's get rid of these because we no longer need them. Now, we are asking for the string title in the constructor as a parameter. This is also the place where we can assign it to the field, to the variable in the class like this. But this has three implications. First, we can no longer create an instance of this book class without providing this value, the value of this parameter, which is a good thing because there are countless examples where a class needs certain resources in order to do whatever it needs to do. So having a way to enforce that whoever wants to use this class must provide these resources is amazing. Second, because this is just a variable, the parameter is just a variable, we can do validations like this. So we can enforce validations like, I don't know, the string must be not empty or null or have white spaces, etc. A valid string, a valid title. Third, since this is called title and this is called title, we have a problem because how would the compiler know to which we are referring? Am I trying to assign this one the value of this one, or am I trying to change this one to the value of this one? No idea. In this case, the compiler, when you have a parameter with the same name as a field, as a variable declared in the class, the compiler will use the one that is closest. In this case, the closest to this point is the parameter, of course. So for all it cares, it sees that we are trying to assign to title the value of title. We are trying to assignment made to the same variable. Are we trying to assign the variable to itself? No. So how do we actually refer to the one in the class? Using this. No, literally this. This is the keyword that tells us that we are referring to the class we are in. So when we say this dot title, we are referring to the book, the instance of the book that will be created here, dot title. So now the compiler sees we are referring to the one in the class equal to the one as a parameter. We are assigning the one in the class the value of the one that is the parameter. So the this keyword can be used to refer to this copy of book, the particular instance that we are manipulating at a certain point in time. Sadly, this is one of the most difficult concepts to grasp by beginners of OOP. I myself had problems when I was a junior, but all you have to understand is that when I say my book.title, this becomes my book. When I say your book.title, this becomes your book. So if I have 10 instances of book, I have 10 this. This becomes every single one when I'm using that one. So this practically holds the state, the values of an object, something like this. I don't know if it makes much sense, but it's not that important anyway, because programmers nowadays, when they have a field, a variable that has the same name as a parameter, they usually put an underscore in front of the field, and then it becomes underscore title equals title. You don't have a this problem anymore. Just like normal methods, constructors can also have optional parameters, can be overloaded, so we can have multiple versions of constructors with multiple parameters of different count or type, and so on. We can also have static constructors, but we haven't learned about static yet. Static constructors are a bit weird. We will, if I don't forget, we will address them when we will discuss about static. Since C#12, we also have primary constructors like this, which more or less do the same thing as the example above. The compiler will create fields for the name and price variables and a constructor with the same parameters to assign them. And it's much more concise, not as verbose as the above example. So it seems nice, but it has a major downside. It has to do with immutability and the read-only keyword we haven't learned about either. But as you'll see in the future, constructor parameters are used a lot due to something called dependency injection. We will learn about it at some point. But dependency injection states that once a variable is assigned in the constructor, it should be frozen, so it's no longer accidentally modifiable. And primary constructors don't do that. So as cool as they may look, don't get used to use them until they fix it to make variables, make fields immutable. Quick mention, if you are not going to watch this entire playlist, don't assign fields directly like you saw me doing my book.title equals. For that you should be using properties, and we will learn about properties in the next clip. As of now, you should have a strong foundation of what a class is, why it's useful, and how to use it. All this material takes a considerable amount of work to produce, so thank me by liking this video and maybe consider becoming one of the amazing people listed at the end of this video by subscribing to the channel so you don't miss out on future topics. For now, thanks for watching and I'll see you in the next tech frame.